Hello, we're going to be covering applications, not a bunch of applications, just a couple example problems pulled directly from WebAssign or are extremely similar to WebAssign questions regarding velocity, speed, time, and solving for those things, basically using derivatives. So if you've gotten this far, I'm going to assume you know how to pull a derivative, so I'm not going to show the exact baby steps for that. However, in regards to solving for these problems, of course, I'm going to show that step by step. So let's get started. A particle moves along a straight line with the equation of motion s equals f of t, where s is measured in meters and t in seconds. Find the velocity and speed when t equals 2. And then here is our function. So the first thing is we need to find the velocity, and then we're going to have to plug in that too. So basically the velocity is your first derivative of this function. So we have f prime equals, again, I'm assuming you know how to pull a derivative, so I'm not going to show every little baby step. I'm going to assume that you know how to do this part. All right, now I'm just going to apply that too, and now we have this. So that is our velocity. But the question is when t equals 2. So all we're going to do is we're going to plug in 2 for t and solve. We get 2. So the velocity when t equals 2 is 2 meters per second. So that is our first answer. I'm going to make sure I write our answers. We'll highlight our answers in pink. All right, so that we don't get any type of confusion. So now we're going to find the speed. So for this specific problem, all right, we are trying to find the velocity and speed at the same time, which is 2. So the speed is our absolute value of our velocity that we found at that time. So we just literally take the absolute value of 2. So what is that? It's literally just 2, right? So it's going to be 2 meters per second. So we have now found both things. We found our velocity, we have found our speed. So remember, that's that, and that is that. All right, now we're going to move on to the next problem. This one's different than the last one. It's going to require a little bit more thinking. So it says if a rock is thrown upward on the planet Mars with a velocity of 13 meters per second, its height in meters after t seconds is given by h equals 13t minus 1.86 t squared. All right, so nothing like a hypothetical question that will never apply to you, right? All right, so let's get started on this. So find the velocity of the rock after 2 seconds. We're literally just gonna do the same thing we did earlier. So feel free to pause the video and do this one on your own. However, I do implore or recommend you wait to do these. These are a little bit different. So we're just going to jump right into this, but again, feel free to try it on your own. So we must first get the derivative. So h prime is literally 13 minus 1.86 times 2t. And I'm going to use a calculator even for the most basics of math because I don't want any errors in this. So then we get 13 minus 3.72. Oh. What am I doing? I'm so sorry. Okay. I literally just trashed t and just solved for it. Okay. So now we have our derivative. 13 minus 3.72t. That is the derivative of our original equation. So now we're just going to plug in 2 for t, and that will tell us the velocity of the rock after 2 seconds. So h2 equals 13 minus 3.72 times 2. So I'm just going to plug that into a calculator. And we get 5.56. So our answer for this is 5.56. So the velocity of the rock after 2 seconds is 5.56. So this next question is kind of silly, but WebAssign likes to give silly questions because why not, right? So it says find the velocity of the rock when t equals a. All it wants is for you to tell it the velocity equation and then replace t with a. So our original velocity equation is just our first derivative that we found, and that first derivative was h prime equals 13 minus 3.72t, but again it's saying when t equals a, so 13 minus 3.72a. That is literally your answer. So if it ever asks you something silly like that, it's just as simple as that. I mean, it's just odd. All right, so when will the rock hit the surface? So this one is a little interesting. I implore you to question yourself. I keep using implore. I need to stop. Okay, I recommend you ask yourself, what do you think you have to do here? I'm gonna give you a second. And I hope your brain went back to all your algebra skills and problem solving skills and said, just equal that thing to 0, right? So we're gonna take our original equation and we're gonna just equal it to 0. I'm sorry, I'm moving up and down a lot. Okay, now let's be normal. So pause this, try to solve it on your own. If you can't solve this on your own, may the gods help you. So let's do this together. We're gonna pull out this t. Okay, now we literally can just do this, and we're gonna have two solutions. Obviously, we're not gonna want that one. We're gonna want the one that gets pulled out of this. Oops. All right, so we set both sides, or both parts, equal to 0. Now we're just gonna continue to solve. So because I have space, I will show every little baby step. All right. All we're doing is getting t by itself, and this part I'm plugging into a calculator. 13 divided by 1.86. I did not include the negatives because two negatives cancel each other out, so there's no point in plugging it in. And we get 6.99 when you round it. So I mean, it depends how they want your answer. WebAssign asks to be rounded to just 1 decimal. So when this gets rounded, you get t equals 7. So our answer for this is t equals 7. So when will the rock hit the surface? T equals 7, right? Okay. So now we're going to move on to this next one. This one's a little funny. It's the same thing, but it does require you to do a little thinking as to how the heck you can put this function into the proper form so that you can actually differentiate, right? Okay, so it says the displacement in meters of a particle moving in a straight line is given by the equation of motion s equals 1 over t squared, where t is measured in seconds. Find the velocity of the particle at times t equals a, t equals 1, t equals 2, and t equals 3. So remember, for that t equals a, it's literally just going to be what we did last time. They just want the first derivative, and then you're going to substitute t with a. But let's take a look at this first thing. This is the problem, right? We cannot take the derivative of this at all. It is not in the form we need it to be in. So I'm going to go ahead and do that now. So, right, we brought it upstairs. That one is still there, but I'm not going to write it because, you know, that's usually implied. So now I'm going to pull the derivative. Remember, I just put it in its form. Now I'm going to pull the derivative. So s prime is negative 2t to the negative 3. All right, so you may leave it like this. Typically, if you're going to find another derivative after this, you leave it like this. But it's also good manners to leave it, to rewrite it as such. And for the sake of solving these problems, we're going to leave it like this. So for this question, find the velocity of the particle at times t equals a. All they want, once more, it's just this. They just want this. So for the problem t equals a, our answer is literally negative 2 over a to the third power, because again, you're going to replace t with a. And so that is your answer for this first one. All right, so now let's continue. Now it's just business as usual. You're literally just going to plug in these values into that equation. So when you plug in 1 for t, we get what? Negative 2, because 1 to the third power is literally just 1, and negative 2 over 1 is just negative 2. So we have found the answer for that one. And of course, this is going to be meters per second. I should probably write that. Okay, so let's move on. T equals 2. Again, just literally plugging it in. Feel free to try it all on your own. It's basic. It's nothing crazy. Again. Okay, for t equals 2, we are going to get negative 1 over 4. And again, I keep forgetting. Meters per second. And then we have that last one, t equals 3. Again, just literally plugging it in. So boring. And we get negative, 2 over 27 meters per second, but that cannot be simplified. So that is our final answer for that one. All right. So find the velocity of the particle at times when t equals a, t equals 1, t equals 2, and t equals 3. Well, we have done that here, right? T equals a, t1, t2, and t3. Perfect. All right, that was a lot. Let's look at this one. This one's a little interesting. I had never really seen it before until now. So let's see. The displacement in meters of a particle moving in a straight line is given by s equals t squared minus 6t plus 15, where t is measured in seconds. Find the average velocity over each time interval. So I recommend you don't try this out on your own right now. Do not pause this video, because you're going to require the average velocity formula. All right, so let's do this one together and then try this one out on your own. So let's do this. So the first thing we have to do is let's identify these. So this is T1, and this is T2. And we need to basically just plug these numbers in to our original function. So let's do that now. Let's plug this in. That's a 3. Again, you can do this part on your own. This is not crazy difficult. It's just basic algebra, right? So we get 9 minus 18 plus 15. What does that give us? 7? No, 6. 6. Let me try to keep this a little neat. All right, and I'm going to write in a different color for this next one. So literally just plugging in 4 into our original equation. We're not deriving crap yet. Well, I don't even think we're going to derive anything. Let's keep going. All right, we get 16 minus 24 plus 15. So S of 4 gives you 7. All right, so basically what we just found, this 6 is S of T1, right? And this 7 is S of T2. So that's important because here is that formula I was just talking about. So we have V average equals S of T2 minus S of T1, T2 minus T1, right? Okay, so that's why we evaluated our function with our interval. So now we can literally just plug it in and figure out what our answer is. So find the average velocity over 3, 4. Well, here we go. We're going to solve that right now. So ST2 is 7 minus ST1, which is 6, over ST2, which is 4, minus ST1, which is 3. What do we get? 1 over 1, and 1 over 1 is literally just 1. So our answer is 1 meter per second for this interval. So let's highlight her in pink. So that is our answer for this interval. So we're literally going to do the same exact thing for this next one. So now feel free to pause it and do whatever you'd like. You know, try it out. Let me know if it's easy, hard maybe. All right, so let's get cooking. So again, T1, T2, we're going to plug these in. So to save time, I'm literally not going to do that 4 because we already have it. S of 4 equals 7, we know that. But we don't know this 5, so let's plug that in. Again, we're just going to plug it into the exact function, the original function that is. 5 squared minus 6 times 5 plus 15. We get 25 minus 30 is 15. So S of 5 is what? 10. Okay. So now we're going to use that average formula, and I'm going to identify these real quick. So remember, this is S of T1 and this is S of T2. So our formula says ST2 minus ST1 and then T2 minus T1. So what does that give us? We get 3. Oop. Okay, there we go. Oopsies. All right, so we get 3 over 1, and that is equivalent to 3, and then meters per second. So that is our answer for this interval. I hope you got that right. So that is it. The average velocity over 4/5 interval is just 3 meters per second. I hope this video was helpful, and thank you.